soy agar, or short for TSA, are growth media for culturing of bacteria. They are universal agar, non-selective media providing enough nutrient to allow a variety of microorganisms to grow. They are used with wide range of application including culture storage, enumeration, isolation of pure culture, or simply general culture. TSA contain enzymatic digest of casein and soybean meal which provide amino acid and other nitrogen substance, making it nutritious medium for variety of organisms. TSA is frequently the base medium of other agar plate. For example, blood agar plate BAP are made by enriching TSA plate with difibrinate sheet blood. There are a variety of nutrients in this TSA agar plate. Among them are 15 gram of tryptophan, 5 gram of soyton, 5 gram of sodium chloride, 15 gram of agar. And this agar is universal to be used in any type of microorganism, except for certain microorganisms that need a specific nutrient to allow them to grow.
Sekali tu dia 27. Alah. Dia ada 3 mood kan. Ni mood 1 liquid. Sama je. 2 baru solid Biasa sama lah ni lah sebab kita autoclave liquid lah. Lepas tu start je lah. Dia sekarang show 27. Lepas tu dia akan heat, lepas tu dry, exhaust, warm, complete. Panas, settle.
dan selamat sejahtera. I'm Nur Faiza and I will explain on anesthesia and pitting. Anesthesia is useful tool for fish veterinary surgeon and enable various tasks to be performed. Fish often struggle when restrained or handled, which can result the damage to the animal and also sometimes to the handler. Anesthesia greatly facilitates examination, transport and diagnostic sample and reduces stress to the fish. Surgery requires anesthesia with an appropriate technique that can maintain fish out of water for an extent of period. The most common anesthetic technique in fish is to add the anesthetic agent into the water and put the fish into the water with anesthetic agent. Next, I will explain on pitting. Pitting is a tactic used to immobilize or kill an animal by inserting a needle or metal rod into its brain. It is regarded as a humane means of immobilizing small animals being observed in experiment. So what we have done was we take the rod and we insert on the head of Carius scarifinus at the end of the spinal cord. We insert and we try to break the spinal cord to stop the electrical impulse. This will eventually kill the fish with a humane means. The next step was dissecting the fish. So what we have done was we dissect the fish through the genital pore until it reaches the skull. After we dissect the fish, we take out all the organs except for the kidney. The next step was dissecting the fish. So what we have done was we dissect the fish through the genital pore until it reaches the skull. After we dissect the fish, we take out all the organs except for the kidney. The next step was dissecting the fish. So what we have done was we take out all the organs except for the kidney. will explain on gram staining. Gram stain or gram staining is also called Gram's method. It's a method of staining used to distinguish and classify bacterial species into two large groups, which is gram-positive and gram-negative. The name comes from the Danish bacteriologist Hans Christian Gram, who developed this technique. Gram staining differentiates bacteria by chemical and physical of their properties of their cell wall by detecting their peptidoglycan, which represent in the cell wall of gram-positive bacteria. Gram-negative cell also contain peptidoglycan, but very small layer of it is dissolved when added with alcohol. Gram-positive bacteria generally have single membrane monoderm and surrounded by a thick peptidoglycan, while for gram-negative bacteria generally possess a thin layer of peptidoglycan between two membrane diadems. This is why the cell loses its initial color from primary stain. Gram-positive bacteria retain the crystal violet dye and thus are stained violet, while gram-negative bacteria do not. After washing and counter stain is added, commonly safranin, that will stain these gram-negative bacteria a pink color. In this experiment, we use four solutions, which is crystal violet, iodine, alcohol, and safranin. Crystal violet dissociates in aqueous solution. This ion penetrates through the cell wall and cell membrane of both gram-positive and gram-negative cell. The Cv+ ion interact with negatively charged component of the bacterial cell and stain the cell purple. Iodine interact with C+ and form large complex of crystal violet and iodine, which is Cvi. When a decolorizer such as alcohol or acetone is added, it interacts with the lipid of the cell membrane. A gram-negative cell loses its outer lipopolysaccharide membrane and the inner peptidoglycan layer is left exposed. The Cvi complex are washed from the gram-negative cell along with the outer membrane. In contrast, a gram-positive cell becomes dehydrated from the ethanol treatment. The large Cvi complex becomes trapped within the gram-positive cell due to the multi-layer nature of peptidoglycan. The decolorization step is critical and must be timed correctly. The crystal violet stain is removed from both gram-positive and gram-negative cell if the decolorizing agent is left on too long. After decolorizer, the gram-positive cell remains purple and the gram-negative cell loses its purple color. Counter stain, which is usually positively charged safranin, is applied to give decolorized gram-negative bacteria a pink or red color. The oxidase test is used to identify bacteria that produce cytochrome C oxidase, an enzyme of the bacterial electron transport chain. Note that all bacteria that are oxidase positive are aerobic and can use oxygen as a terminal electron acceptor in respiration. This does not mean that they are strict aerobes. Bacteria that are oxidase negative may be anaerobic, aerobic or facultative. The oxidase negative result just means that these organisms do not have the cytochrome C oxidase that oxidize this test reagent. They may respire using other oxidase in electron chain transport. So, when we carry on this oxidase test, we will get two results, which is either the bacteria will change color into blue, dark blue, or it remain unchanged. If the bacteria does change its color, that means this bacteria is aerobic bacteria and contains cytochrome C oxidase. If it doesn't change color, that means this bacteria is anaerobic bacteria and does not contain cytochrome C oxidase. Assalamualaikum. Now I will explain on catalase test. Catalase is a common enzyme found in nearly all living organisms exposed to oxygen, such as bacteria, plants, and animals. It catalyzes the decomposition of hydrogen peroxide to water and oxygen. It is a very important enzyme in protecting the cell from oxidative damage by reactive oxygen species. Likewise, catalase has one of the highest turnover number of all enzymes. One catalase molecule can convert millions of hydrogen peroxide molecules to water and oxygen each second. The catalase test is used to differentiate between staphylococci, which is catalase positive, and streptococci, which is catalase negative. The enzyme catalase is produced by bacteria that respire using oxygen and protect them from the toxic byproduct of oxygen metabolism. Catalase positive bacteria include strict aerob as well as facultative aerob, although they all have the ability to respire using oxygen as their terminal electron acceptor. Catalase negative bacteria may be anaerobes or they may be facultative anaerobes that are only ferment and do not respire using oxygen as a terminal electron acceptor. So when we carry on this catalase test, we will get only two results. When we mix the catalase reagent with the bacteria will either bubble or do not bubble. If the bacteria bubbles, that means this bacteria will use oxygen to respire and it is an aerobic bacteria. If the bacteria does not bubble with the reagent mix, that means that this bacteria is anaerobic bacteria and only respire through fermentation.
Michael?
Don't. We're married.
It's okay, I don't mind.
पलकों के लेके पागल दिल को दिल धड़के ही जाए, पर सोच लो इस पल है जो वो दास्तां कल हो न हो। हर घड़ी बदल रही है रूप जिंदगी माँ, कल हो न हो। हर पल यहाँ